Good afternoon, ladies and gentlemen, and welcome to this Earth Observation Data Panel discussion. My name is Kunwar Singh, and I'm a Senior Geospatial Scientist in AidData at William & Mary. It is a great pleasure both to participate in the panel as a moderator and to welcome you to this event. The topic of the panel is the Earth observation data, open access availability, uptake, and constraints. When we choose the topic a few weeks ago, it seems topical. It seems even more topical now. I will set the problem statement. I will ask panelists to introduce and provide a brief statement. And I have a set of questions for panelists. Once we go through those questions, I will open this discussion to audience as well. We will keep conversation, suggestions, questions short so we can have more interaction, more outcomes. So I'll begin with the problem statement. The potential for Earth observation to guide investment towards cost-effective statement that most likely to work, produce maximum benefits, and to reach the most people has not yet been fully realized, though undisputedly needed. This assertion has, if anything, been sharpened by various talks and discussions during the last 2 days at this convening. We all agree, however, that Earth observation has provided an invaluable perspective on the dynamic landscape of Earth since the early 1970s, and that has enabled unprecedented insight into global environmental changes. Recent innovation in cloud computing, growing built-in data catalogs, and sophisticated methods to analyze Earth observation offers opportunities to rigorously evaluate the impacts and cost-effectiveness of climate-smart development interventions. However, there are several unanswered questions benefiting to this panel for discussion, such as how Earth observation has contributed to agricultural impact evaluations, and what are the new prospects to increase its uptake to support the decision-making process, specifically in countries that are facing climate change at an accelerated rate. Deeper insight into these questions are needed to forge a path forward to ensure its uptake and its successful translation into tangible actions, whether in environmental conservation, agricultural, disaster management, and other sectors. It involves integrating Earth observation technology into existing workflows and decision-making processes. During this convening, we all experienced the multidisciplinary nature of GIs, geospatial impact evaluations. Success of geospatial impact evaluations depends on true collaborative effects from multiple disciplines, specifically intra-governmental collaborations that facilitates GIs by leveraging the expansive reach of Earth observation technology. Perhaps this panel can help review traditional impact evaluation methodologies, highlighting the transformative impact of Earth observation data in shaping agricultural strategies. But now, an even more fundamental questions needed to be addressed, and that is, what are the trade-offs between open access, moderate resolution imagery, and proprietary high-resolution imageries? This brings another interesting topic of nascent development of Earth observation and cutting-edge advancement for the panelists to consider. Against this broad background, the panel will discuss Earth observation's profound impact on agricultural impact evaluations, the collaborative potential between governments and stakeholders, and the transformative role of emerging Earth observation technologies while navigating the intricacies of data access and quality and valuable insight into the evolving landscape of agricultural assessment in the modern era. We have a distinguished panel with us. In a fundamental sense, they needs no introduction, so utilize their time more efficiently and to make the best possible outcomes. I will ask panelists to start with a few minutes statements and with a brief introduction. Rocio and Pierre are not with us in person, but I hope they are on Zoom and hearing us. So without taking further time, I will ask panelists to begin. And first, I will invite Rocio.
Hi, Kunwar. Hi, everyone. First of all, thank you so much for having me here. It's such a great honor. I'm so sorry I'm not in person, but I'm really excited about today's panel and can't wait to hear from our peers. So, my name is Rocio Carrero, and I work as a customer success manager for education and research at Planet, which is a private company based in Silicon Valley, and they manufacture satellites, send them to space, and sell the data. My background is not in the private sector. My background is in academia and government. I work for academia and government for over 10 years, specifically in climate change adaptation. And I feel privileged now to work at the other side and collaborate very closely with all researchers and institutions that want to leverage the power of Earth observation for our very critical issues that we have at hand. Um, I don't have a presentation today. I wanted this to be a conversation that flows more organically. I really want to hear from the other panelists and participants, but my statement would be that I believe remote sensing, especially proprietary remote sensing, is here to help and to enrich an already available public data set that is really, really useful when we have new capabilities that now are provided by companies, and they offer incredible products in terms of spatial, temporal, and spectral resolution. And those products can help to fill the gap where the public imagery is not enough. But I think the most important question when designing any project or any impact evaluation should never start with the imagery. It should always start with the goal and with the objectives, and then after that, selecting which data sets will be more beneficial for those objectives. There is a lot to cover today. I am particularly excited about the topics of interdisciplinarity. I am a firm believer that we need to bring people from different fields. I believe that remote sensing by itself is not enough. We need the topical expertise. We need sociologists. We need agronomists. We need climatologists. We definitely need local knowledge, local communities. I come from a local community, a fisherman community. That's my family. And I think without involving local communities into the design of the methodologies, when we are at the beginning of the first phases of any impact evaluation or any research project, without that, the project will fail. And we might establish objectives and operational objectives that are not feasible. So yes, I'm excited today to discuss how remote sensing is just another layer, an important one, a very powerful one, but another one that has to be integrated with the different knowledge and teams that we have in our different projects and organizations. That's really what I wanted to say. There is a lot to talk. I, of course, can discuss the new developments on satellite imagery, but I would love to give the time to my colleagues and hear from you and be available for the questions that come. So thank you so much, Kunwar.
Thank you very much, Rocio. Our next panelist is Pierre Sibiry. He will represent NASA.
Well, thanks very much, everyone. And sorry to the colleagues that I cannot meet you in the room today because I guess I'm radioactive, hopefully not with what you know. So I'm joining you from my beautiful hotel room in Rome. And as a way of introduction, I'm Pierre Traore. I've been with ICRISAT for 23 years. That's the International Crops Research Institute for the Semi-Arid Tropics. I have no expertise in impact assessment or in impact evaluation. My background is in remote sensing. And I have the privilege, I would say relatively unique, of being embedded as a scientist in the private sector in a company called Manobi Africa that is headquartered in Mauritius, but I am based in Dakar, Senegal. What I do in this position is that I work on the development of approaches to essentially link farmers to markets and business opportunities. We also intervene in a couple other sectors like water distribution. What we essentially do is use digital platforms, but also value chain expertise and proximal presence to build what we call phygital agriculture and work to orchestrate the creation of value in smallholder agricultural value chains. In that context, remote sensing has a very high potential, specifically to reduce the operational costs of monitoring farmer compliance with a number of good agricultural practices. But perhaps more interestingly, it also has the potential to help monitor next users' compliance with best practices. And by these, I mean particularly the financial sector. And I will try to give a few quick examples of that through slides in a moment as we progress through the questions. To conclude, I'm a firm believer in the value of remote sensing, but I'm a strong opponent to supply-driven approaches, tech-driven approaches. I consider that, as the previous colleague said, setting the right objectives, understanding the system, what are the main bottlenecks and opportunities for improvement in efficacy and efficiency are key before you can really assess the fitness for purpose of remote sensing and Earth observation products. So I am very keen to hear from the other colleagues on the panel, and I thank again GeoField for inviting us here, and look forward to the discussion. Thank you.
Thank you, Sibiry. Our next panelist is Rahul Garg. Yeah, the purpose of this presentation is just to show the potential of remote sensing technology for finding out the trend analysis for an arid region. I hope you all are aware that Jaisalmer is one of the arid region, one of the very acute arid region of India. And there we have one IGNP, Indira Gandhi Nehar Pariyojana or Indira Gandhi Canal Project. So just we tried to evaluate the scenario just in the neighborhood of IGNP using the three properties, that is soil moisture, NDVI and LST, and which were obtained from the satellite data. And satellite data taken by us is MODIS, because MODIS has got very good temporal resolution. It means every second day that this MODIS data is available to you. If you want to study your crop, although it has got poor spatial resolution, that is
about 1 kilometer, but still you will be able to do analysis of very vast area of the croplands. So in this particular region, crops are not many because there are only 2 seasons. I hope we all are using the 3 crop seasons in different part of the world. But in this particular area, only 2 crop seasons, Kharif and Rabi, are there. But this is giving us, this analysis is giving us very good representation regarding the variation of NDVI, and NDVI is directly related with the vegetation as well as vegetation stress. And that too can be correlated with LST, land surface temperature, and then again with respect to the soil moisture, we will be able to establish a trend. So you see that, where is the presenter? It is not moving forward. Yeah, okay, I think. Just if you can give me presenter, it will be good. All right, this is a picture of that Indira Gandhi canal project. It is about 300 kilometers long, and after this project has been executed, there has been drastic change in the morphology as well as vegetation status of this area. You can see that this area, this canal we have studied, we have taken a buffer of 20 kilometers wide, 10 kilometers on each side, and this has been studied for variations of the properties. As you can see, this is the elevation model. In the southern side here, okay, I think it will not work. In this south, this eastern side, we have got high elevation. On the other side, we have got lower elevation, which also is commensurate with respect to the flow of the channel. So here we have got variation of different type of elevation data with respect to this. And now I will directly come to methodology. So the parameters studied are NDVI, LST. We have done data pre-processing. The data has to be corrected. And now for the 3 properties, 2 type of trend analysis algorithms have been used. These are the modified man-candled and that linear regression. So just finding out correlation between these. And as such, any expert, any agriculture expert in this field can say that, okay, I already know the findings, or it is in line with the popular belief. But what I say that if the same findings can be justified by remote sensing data, it means I can use it in some unknown areas also. It says that remote sensing can give you the data, it can give you the results, which are as per the normal type of justifications. So this is the buffer for individual region. In fact, we have taken 1 kilometer wide buffer only because we want to study the property for that region. And it is for NDVI. You see that we have taken for 4 months. We have taken average of those months for the 21-year span of that. Like it is March, May, August, and November. It is for 1 crop cycle as such. You see that earlier for the NDVI, the trend is more or less normal, and it is also seen when we go beyond 10 kilometer wide buffer on one side. The trend becomes diminishing, that there is no more variation. That's why we have taken up to 20 kilometer wide only. And this is for all other properties. You can see it is for LST. Sorry. And then we go for NDVI, people may worry like why this curve is flat, while on the other side the curve has got too many jerks and too many peaks and troughs. This is due to the normalization. If we normalize the curve, it will become the previous one. It is showing the actual value of NDVI, other thing. And on the other side, you can see the blocks plot, which can show you the variance, the central value, as well as the quartiles of this variation. Yeah, again, we have got the variation with respect to different months. We see that with respect to the various months, NDVI is also varying as such. And if you see the legend, The brown part is a lower part, and this blue part or cyan part is the more NDVI. It means the variation of NDVI is also as per the upstream property of the canal. So then we go for the other property, this for the trend analysis, that sane slope and the and this other one. You can see that the properties are going as per the this various valuations of this particular area. Now again we have got that LST variation and the box plot of that. You see that LST variation with respect to different months also is given over here. So LST is showing a trend that when NDVI is high, LST becomes low. So this also can be proven in this particular curve. And then we have got the trend analysis for this. So trend analysis sometime is better. If we study only the monthly variation, it may not give us idea, but trend analysis gives you the idea because it has been seen. Almost 25% of the area shows the negative NDVI for different months, while 75% area has got positive NDVI. So it is just a positive indication regarding this analysis. You see that various average surface soil moisture for this area. And then we have got sane slopes. Again, for surface soil moisture also we have got this. Then we have got the values for the correlation. It shows that March month has got a better correlation in comparison to May, August, November, etc. This is one field picture wherein the GPS data has been taken as well as field photograph, Google image, and the sample. Sample has been used in order to collect the hyperspectral spectrum of that. So in the laboratory using the spectroradiometer, we could collect this spectra of that. That has been used for further analysis for finding out the soil properties and other things. And in fact, one more objective of this project, although it is not covered here, how to find out property of the unknown area, this property of soil for the unknown area. Can we establish some relationship looking at this position, this data, this validation can be extrapolated over there. So with this, I close my presentation with some conclusion. These are just whatever I have told earlier, that agriculture and other activities, L regression and modified Mann-Kendall test gave better results, etc. etc. Thank you. Thank you for your attention.
Thank you, Rahul. Thank you, Rahul, for sharing a wonderful example of your work. Our next panelist is Christoph.
Right, while the presentation is being prepared, I want to give you two caveats to my contribution here. The first one, when I was invited to the data providers panel, I actually said, no, I don't want to be on a data providers panel. But if you have the ICRISAT tag, I guess there's no way out of it, unfortunately. I wanted to be more on the user side. The second caveat is I was planning for an 8-minute presentation, so now I was told I have 4 minutes, so I will plan to only show you every second slide and let you make sense of the rest. And actually, I already used 1 minute, so I only show you every third slide. All right. All right, let's go ahead. So I want to show you a bit about data. It's a data providers panel, which may have not been so obvious from the previous presentations, but it's a data providers panel, so we have a really amazing time right now. I mean, we are in a new era. We feel the pulse of our planet, like we say in ESA Earth observation, and we collect a lot of data that is potentially useful for development. And I would argue that there is really no justification anymore not to use that data, be it for impact evaluation or for planning, design, for whatever else. I think as ESA, we contribute our fair share to that, particularly through the Copernicus program, obviously. A lot of you have mentioned the use of Sentinel-2 and some even Sentinel-1, which was quite nice, over the last sessions. So just to maybe highlight, we are currently collecting and distributing about 300 terabytes of satellite data per day. So obviously, I don't encourage you to download that or do something with that, but it also shows that we have a transition in how we manage and work with data. We need to move to the cloud. We need to kind of be more efficient to take the data to the user, or actually take the user to the data to make the things work and achieve our objectives. I very much concur with the statements of the fellow panelists before, to be against supply and tech-driven approaches, especially in development. It has to be demand-driven, and we have to put the objectives first, which is really something we do also in the program I manage. Okay, that's a slide I skip. You've seen it. You know how the satellites run around, so it's still pretty cool. But, we are also focusing on the next generation of satellites and sentinels. One of these being specifically focused on food security also. We have hyperspectral missions coming up, new radar missions, etc. But again, this is one of the slides I skip. So how do we handle all this data? One way could be to call Bruce Willis. I say, no, call ESA. Anyway, it's after lunch. I know I'm not very funny. I'm trying to, keep it entertaining. So the program I manage is called Global Development Assistance, GDA. And actually, we work with international financial institutions like the World Bank, the regional development banks, ADB, IDB, EIB, AFDB. We have a lot of, TLAs here, 3-letter acronyms, but I don't bother you with it. So it's all about leveraging partnerships and supporting those in need. And I guess this is what we heard a lot over this couple of days. Another slide I'm going to skip. It's the history of, where we come from in the project that I manage, or the program I manage now. It's actually just to illustrate that we've been doing this for a long time. We started 15 years ago to engage with the World Bank and others. And it's all about fostering actually adoption. And that's something I think that's also at the core of this workshop, fostering adoption, going beyond the just use of data for pilot studies. So maybe to move ahead and show you a few examples still. Another slide I skip. The way GDA is structured is really demand-driven. We don't push the technology, but we actually ask our partners, what do you need, both in terms of data, both in terms of analytics, but also in terms of programmatic support, and then we work with them to make it happen. So actually both World Bank and ADB have put in place dedicated programmatic structures to complement what we do. And we work together with them, we coordinate resource mobilization, etc. And more than 100 million have by now been mobilized to actually push this mainstreaming of Earth observation in development operations, both through dedicated finance, trust funds, through programmatically aligned finance, and the ultimate goal is to mainstream in development operations, in lending, loans, credits, etc., to make the countries ask for it. We cover a number of activities and thematic domains, agriculture being one of them. I don't go in more detail, no time. But we have also a dedicated M&E approach, which is interesting. I mean, we talk here about using Earth observation to support monitoring and evaluation, but actually I use monitoring and evaluation to support Earth observation, kind of the other way around. Anyway, we do both, obviously, but it's interesting because it gives us a nice guideline how to set up, a structured M&E framework. We sometimes get lost on the data side, on indicators and so, but we need to have a concrete theory of change, an impact pathway. What do we want to achieve? Not just measure anything and then see if it's useful, but let's see, we want to measure that and then we do it and measure ourselves against it. So that's the theory of change. Don't bother. But there is a video online which illustrates it nicely, so I would encourage you to check gda.esa.int. What is maybe more interesting is that it actually works. We see that over the last decade or so, the proportion of World Bank project documents that mention Earth observation or anything related is really increasing vastly. So we see that there's more interest, more demand, and we are trying to capitalize on it and build on that. So now the other way around, not M&E for EO, but EO for M&E. We do that too. And actually, it's very interesting to see, just using the World Bank as an illustrative example, this the standardized investment project cycle. I think all the IFIs have something similar. Earth observation can actually be useful in all cycles. And evaluation is one of that. It mainly happens in the implementation and support stage, when you monitor, when you evaluate, and then you do impact assessment afterwards. So we made a quick check in the projects that we support right now, and quite a few of them actually have a dedicated focus on M&E and impact evaluation. So it's increasingly being asked for in terms of the support that the IFIs ask us to provide. This is something that friend Arthur, I don't know where he is now, I can't see him, but mentioned in the previous session, the distinction between the responsibilities of the client and the bank itself, or the IFI itself. So you have supervision on the one hand, which is the responsibility of the lending entity, the bank. They look a lot about agreement and compliance with financing agreements, environmental, social standards, etc. And then you have the side of the client, the borrower, who actually is mainly interested in monitoring the progress. Right? So there are different objectives, but essentially a lot of it is sourced out to third-party monitoring, and that's where Earth observation can play a strong role. There's one initiative I'd like to highlight, the World Bank's GEMS team, Geo-Enabling Initiative for Monitoring and Supervision. They do a great job, not using much Earth observation yet, but we will work with them. They do a lot of ground-based work on geocoding, georeferencing, etc. But in one of our upcoming GDA activities, we actually plan to work with all of these IFIs to help them roll this out in a more standardized way. So I can skip that one because I think our IFAD colleagues have already showed enough examples on how they use EO for M&E and GIS for M&E. Again, the report has already been shown, so I move on. Actually, I also skipped this one because it's not particularly linked to agriculture. I think it's still a nice example on using Earth observation for monitoring and evaluation. This is linked to checking informal trade patterns, which you don't get in the surveys because you have more continuous observations, and it can complement the assessment of enhancement of regional trade, but no details. This slide I added, and I'm almost at the end of my still 8 minutes eventually. It's the use of Earth observation in inaccessible areas. We had that already before, and we did actually a support project with the World Bank on Syria, which is quite interesting to see the effects that the conflict has on agricultural productivity. So what we see here is the change, pre-conflict to during conflict. Unfortunately, we can't say post-conflict. In terms of the cultivated area, and we can actually really see the change from active irrigation patterns to rain-fed irrigation because the irrigation channels were destroyed, etc., etc. And you can't send anybody there, but you can still do remote sensing analysis and do ground-based cross-checks with similar neighboring countries. So actually we did the cross-validation with the border area of Turkey. With that, I actually want to still maybe highlight this MOOC for you. If somebody has a lot of time later, you can check that. It gives you the whole idea and good learning on the usage of space for international development assistance. And I say thank you.
Thank you, Christoph. I hope we didn't miss some important slides, but time is the constraint and we have to follow that. So our next panelist is Vivek Sakhrani.
Hello, everyone. So I'll try to keep this as brief as possible to help us get back on track. So Atlas AI is a software engineering firm. We have figured out ways to take 300 terabytes of data that Christoph and his colleagues are making available to the world for public benefit and find a way to connect that with demand that we receive in the marketplace, but also importantly in the policy and investment space for public benefit applications, whether it's in agriculture, other SDGs like energy access, water and sanitation, and overall poverty reduction. So Atlas AI was founded by 3 Stanford professors, one from computer science, another from Earth observation, and the third from development economics. So you could see the 3 pillars of our work coming together in the way we've talked about it this week. We are today building data products and algorithms to use those remote sensing-based data products for a variety of applications. But the vision, there's a single vision underlying all of our work, which is to help actors anticipate, monitor, and act to address dynamic global change, right? So this takes us far beyond just environmental agricultural applications into socioeconomic, built environment, and global macro trends as well. So to sort of seed some of the comments that Kunwar has already asked us, we are working today with the 50 by 2030 program, Data Smart Agriculture, helping countries build up their ag data collection and management systems. A very large undertaking with partnership from ITAD, from IFAD, from FAO, and the World Bank. There we're doing some of the new science that is being asked about in one of the panelists' questions. So ask me about that, and I'll tell you about the role of ground truthing and how we're now starting to think about the need for labels and improving that. Also ask me about capacity building in terms of how we're working with country offices and national statistical agencies in learning how to do that collection on their own and implement machine learning algorithms to generate their own crop type and yield estimation activities. With the Rockefeller Foundation, we're working on an idea called interconnected pathways to development. So we're looking at the interrelationship between the agricultural system, energy as productive use, and transportation as sort of three key systems that interact together in most of the smallholder contexts for delivering the beneficial output of the agricultural sector to markets and to economies. And then, of course, there are several details that we could also get into in terms of new science, but also opportunities for public-private partnership collaboration as one of the entities in the value chain that is bringing, again, Earth observation technology, but really connecting that to where we see demand signals from policy and markets. So I'll pause there and look forward to continuing in questions.
Thank you. Thank you, Vivek. And our final panelist is Ranjita Puskar.
Thank you. Thanks, Kunwar. Yeah, Earth observations, important, huge potential. We are talking about climate change, which I'd like to call, is a wicked challenge, not just complex. And these crises or shocks are not coming one at a time. We had COVID, we have climate change, and then we have conflict, everything going on at the same time. So it's indeed a very, very dynamic world. So, and then these are situations where, as Christoph said, you probably can't travel to a lot of these places. So how do you monitor what's happening? And I think that's where there's an awful lot of potential. And how do we use this to direct our investments so that we are better prepared for the next shock that is coming our way, the next crisis that's coming our way. Having said that, one important thing that I'm taking away from here is something that Tulika brought up in the panel she was moderating a few times yesterday. We are doing a lot of stuff on shocks, but what about the stresses that are there all the time? What can we do about those? And I think that's something we can't ignore. Those are gradually eroding the resilience, the capacities of people to respond and cope. So that's something I think we should be thinking of. A lot of advances have been made, but then I think we still have a lot of methodological challenges. And I think even taking a step back, I mean, I have a long wish list of things I'd like to see happen using Earth observations. I'm a social scientist. I know a little bit of impact evaluation. I have no idea about the technicalities of these Earth observations, but I have this list. But what are the right questions to ask? You know, what questions should we be asking? What are amenable to be given, you know, to be generating answers for? I think these are still discussions that haven't happened quite widely and I think need to happen. And that's where I think this whole thing about multidisciplinarity or interdisciplinarity or even transdisciplinarity comes in. And as we are talking about evidence and directing investments, it's important that we are not supply push, but then demand driven, understanding who's looking for this information and knowledge and data, what are their needs, what are their evidence needs, and then gearing our investments in research and M&E and impact evaluation to answer some of those. Very few agricultural impact evaluations using Earth observations, as we've seen from yesterday. I mean, there is a move towards that, but I think we still have long ways to go. I've been in the last few, I mean, a year and a half or so, have been looking at evidence, trying to collate and synthesize evidence around impacts of climate smart agriculture with a particular focus on gender and social equity. What's happening there? Hardly any. So many of us, many agricultural researchers here, developing an awful lot of climate smart technologies. We talked about varieties yesterday. We talked about things like alternate wetting and drying, and there's a whole host of others. But who's adopting them? What are the outcomes and impacts? Who's benefiting from them? Men, women, rich, poor, large landholders, small landholders. I don't know if these questions are all possible. I mean, if it's possible to answer these questions through Earth observations, I don't know, but I think these are important questions if we are looking at scale and deep changes and all we are talking about. And I think we focused quite a lot on production so far. Still a bit of an obsession with yield, I think, but I don't know if it's possible to move beyond that. Shouldn't we be looking at food systems? That's the framework that the FAO or IFAD or, CG has been adopting. I know FAO, I mean, yesterday there was this great presentation about the FAO program looking at value chains and so on. So how can we take it to that other level? And then we are talking about bringing together, Earth observations with survey data, but then also social sciences, we're increasingly moving towards mixed methods, quantitative, qualitative, but then we should also bring in the Earth observation, I think. So again, importance of multidisciplinary teams and so on. So thank you.
Thank you, Ranjita. I'm going to start off with a question for all our panelists. We have discussed a variety of different ways Earth observation approaches are contributing to agricultural impact evaluation, but what in each of your mind are the most important challenges for agricultural impact evaluation that Earth observation integration could help address?
Yeah, I'll focus my comment on producing the base data for sort of post hoc evaluation or even for baselining in relation to ground reference information that's needed to first and foremost produce those indicators. So I think a continuing challenge remains, can we get good labels for producing crop type maps or crop yield estimates and so on? And often as we were talking in several sessions yesterday, this enters into the realm of uncertainty, where we acknowledge some limitations and caveats related to what's available, and then we are left with some of the outputs at the end of that process. So I think some of the recent work we've been doing is asking the question of how many labels do you actually need to produce a robust or highly confident crop type or a map or yield estimate? And is that 1,000 plots? Is that 1,000 parcels with some subplots in there? Is it 10,000? Does it vary by crop type? So actually doing research on the methods themselves to try to understand, can we do more with less? And a lot of the work that's been published along with colleagues at the Living Standards Measurement Study Group using integrated surveys on agriculture data is showing that we can actually do a lot more with less. And so by limiting the number of labels that are needed from the field to those areas that are highly promising and have the most likely impact, there's ways to further standardize some of those models.
I could perhaps provide another outlook if you wish, Kunwar. Should I go ahead?
Yes.
Yeah, so I'm sharing a slide and I guess you should be able to see it. I think one of the main challenges to incorporating EO in agricultural impact evaluation is to make absolutely sure that we understand the system that we're working with. Yesterday, Sean talked about establishing causal inferences and working it into the EO workflows. That is absolutely essential because it's the only way we can actually exploit remote sensing in a sensible fashion. I often think that in smallholder settings, precision ag is not a variable rate technology that responds to variability in the biophysical environment. It's a set of intelligent engagement processes that respond to variability in the socioeconomic and political environment. For example, if you don't know that labor shortage is an issue, then you will confuse green weeds for green crops in satellite imagery. So you need to get access to that very nuanced information of the political economy and the agronomy, for example, of the system. Why does a smallholder farmer who is bound by a sales contract will harvest at night to hide part of the harvest? Why does a smallholder farmer side sell? How does a champion tech adopter exploit development projects to deprive actually fellow farmers in the same community of capital assets? There are many aspects of these that relate to the fitness for purpose of remote sensing, and also people need to understand the scale dependencies in the system. And one example that I can provide on this is taken from the Copernicus missions, again, on the Senegal River Valley. That's work we've done with our partner Accelerant and in the context of the Heuristics project, where you can see in the central frame that the harvest date estimate from smallholder fields on rice was late in 2020, and we were able to associate it with interregional lockdowns, reducing the amount of labor available to conduct the harvest. But if you look at the insert on the right-hand side, you will see that at a more granular scale, at the scale of maybe a 5,000 or 6,000 plots irrigated scheme, you will find a polar opposite to that situation. And that is very often linked to the availability of inputs for a particular farmer cooperative that actually dictates, on top of the pandemic and other aspects, the speed at which they will be able to put their crop in production. I will provide further example on the next question. Over.
I would like to add another layer to what the colleague said, that from what I've seen in the many teams that I work with is that right now, Earth observation has moved already to the big data dimension and to the AI dimension. And while many teams that I work with have experts in remote sensing or EAS, they sometimes lack expertise in computer sciences or AI. I think that is a constraint and something that it would be really advisable to build capacity as soon as we can, because the people who have the more computer science capabilities in the team are the people who can take a question, as the one that said the panelists before, how could we incorporate gender, or how could we simplify or bring down the cost of labeling? If a person have that know-how, they might think on something like, hey, let's try new algorithms, let's do SAM model. But if you don't have that person in the team, you're going to be limited in the way you can apply the technology. So I think it's really paramount to increase the availability and the connections to this AI, computer scientists, engineers, experts, and women into the room.
Yes, please. Okay, my turn, I guess. So actually, I first want to say that I'm actually now quite happy to be on this panel. So thanks for inviting me again. Fantastic discussion. You asked us what we think are the most important challenges on the use of Earth observation. So I think that, those challenges should be our goals that we want to address. So I don't want to go into the tech side here. We've already heard a bit on that, and I think especially the space agencies like us or NASA or the Japanese and the Indians, etc., we are focusing on advancing the tech side, the sensor specifics, etc., together with user communities. Like the next generation of Sentinel satellites is designed after a thorough review process with the user community. So I don't want to go into this now. Rather, in the development context, I think that what are the challenges that we want to address and where we feel Earth observation can help is increase efficiencies of development interventions, right? And that doesn't only apply to agriculture, but basically where, how, when to invest. Often this is done like this and still nowadays, and we can be better than that. Fostering transparency and local co-ownership, I think this is key. You know, with Earth observation, especially with openly accessible data, a lot of this can be used to justify, to actually even testify. I mean, a lot of the Sentinel data has even been used in court by now to testify on certain interventions and actions. Co-ownership, I mentioned, I think is key. We need for it to be sustainable and mainstreamed. It can't be us pushing, it needs to be the local ones using and demanding it, and the more it's open and the more it's understandable and user-friendly, the more they will co-own it. And plus, we can do it all at scale, because we have been doing pilots and pilots and pilots and more pilots over the last 20 years probably, and these are all good to build our evidence base, but if we really want to have an impact, we need to be able to roll it out at scale with institutions like FAO, like the banks, etc., who have this, you know, scaling mechanism to really transfer success stories from one region to the other, learn from each other, etc. And with that, I guess we can really then accelerate development outcomes. I think that's the ultimate goal, and at the same time, the ultimate challenge.
Okay, thanks for giving me this opportunity. But I feel that almost all the aspects of agriculture are very much challenging for the EO integration, because an Earth observation person has to move forward with a lot of parameters which are required for agriculture. Just for example, if we start with climate, the climate suitability of the crop is very important, and nowadays it can be given by the EO data, as well as I always give importance to the ground data, because number of observations, number of records have been taken earlier. So a good integration is always required, rainfall, prediction, other things. Soil suitability is the most important thing right now. The farmer should know the property of the soils. Although farmers are very clever, they know from their internal insight about the soil property, but still, if the new technology can help them to choose a particular crop which is suitable for the irrigation facilities available and the crop and the soil properties, etc., that will be a win-win situation. The flood warning, if it can be given to the farmer earlier, it will be good. So EO can help in all these things. Yield estimation. Nowadays, yield estimation is being done by number of models, and a number of these models are giving very good results also. Although there is a question that this model is not able to give 80% or 70% accuracy, but still I feel that much is enough for starting. And again, on that, crop insurance is very important thing, which is of benefit of the farmer community, because once we come out with a scientific modality of fixing the insurance amount as well as the premium, etc., it will help the farmer too much. And what I feel that most important of all that is the land ownership. Because for developing countries, land ownership records are still not good. I can share one information for India. India has made this UPIN, Unique Property Identification Number, for almost 50% of the Indian agriculture and other lands. So once a person, one agriculturist has got all these information, then it will be very good usage of EU data for all his purposes. Thank you.
Thanks. As a user and a collaborator, the questions I'd like to see asked and the challenges we want to address is sort of understanding the impacts of climate smart agriculture and how we can scale climate smart agriculture. How can we use Earth observations for foresight to sort of be able to advise the communities and the governments, investors on the right things to focus on. Thank you.
Thank you. We already reached to time when we have to have a coffee break. But if you guys allow me and panelists, while you guys take coffee break slowly, gradually, we can have a few questions from audience as well. Because I have a long list of questions. I doubt if we can even get to the next question. So while you take coffee break, if you are okay, we can also have questions from you guys as well. Is that yes? Okay, great. So, thank you. So if you guys have any question or suggestion, please go one by one, yeah. Please raise your hand, state your name, and go ahead, yeah.
Kunwar, perhaps I'd like to make a quick other intervention, if you will allow me, until the questions come.
Sure, please, go ahead.
Because there was a very good comment by our colleague from Atlas AI about ground truth, and yesterday I was sort of challenging people about ground truth. So I'm just showing you one quick other aspect that I think you can see my slide, right? I believe that there is no such thing as ground truth. And in fact, there is no such thing as probably space truth as well. Both are what I would call complementary glimpses of system states that are spread across space and time, and each of which they have strengths and weaknesses and a particular fitness for purpose. And something that I believe is particularly important for impact assessment is that, as was said yesterday, a good enough handle on a socioeconomically meaningful agronomic process may be more valuable than a highly accurate estimate of a transient symptom of technology adoption. And by this, I mean, and that's why I was telling that if you're able to monitor in a system the speed at which farmers do certain classical agronomic operations, it already provides you a lot of information about their ability to adopt. And I just want to show one slide that illustrates how we do this, is that we actually use remote sensing as a way to tighten the field data collection process by extension agents, where remote sensing is going to help identify deviations in the field data quality and help tighten them and raise flags for anomalies that might need to be corrected. But where it's really interesting is that at the higher level, if you look at this graph, you will see that the red curve demonstrates the cumulative flooded area for a rice-growing region. And you will see that somewhere in the red curve in the middle, there's a plateau that is seen by remote sensing. And that plateau actually corresponds to farmers first responding to the prospect of getting agricultural credit when an announcement is made, and then stalling their flooding, and then restarting it once the credit starts to flow through. So I want to show this specifically because the government of Senegal and the SAID, which is the agency in charge, and for example, provide those orange and green curves, are not able to see that level of incidence or impact of the proper behavior of a banking system providing credit early enough for farmers to buy the inputs and do all the production practice, whereas remote sensing is able to do this. So in conclusion, I'd like to also appreciate the fact that if you want to use this to, for example, monitor alternate wetting and drying on rice, or the system for rice intensification, you could think of devising it along the lines of, how does remote sensing or Earth observation help me decrease the cost of qualifying farmer compliance with that particular practice? And then you can use it as evidence to, for example, unlock green financing or things like that. That's what I wanted to show over.
Thank you, Sibiry. Please go ahead. Yeah.
Very outset, thank you very much for arranging this very important session on open access availability, uptake, and constant. And I would like to thank the elite panel sitting over there. I really wanted to listen about the open access availability, but least has been said, I believe. I don't know what would have been the reason, but I believe that the accessibility of the data, and that too in open domain, will greatly help all the users, including private agencies and the government agencies. And when the data is made available free of cost in open domain, then multiple uses, multiple success stories, and the tools and techniques would be developed. Thanks to ESA and NASA for providing a beautiful data set of Landsat and then Sentinel that has made possible a number of studies, and we can easily recognize almost all the examples and studies. Those have been shown in 2 days. Those are relating with either NASA or the Sentinel. So my appeal to this community would be whether we can also think of having kind of a constellation of satellite with very, very high resolution, which everybody is demanding, and everybody is complaining as to the data is very costly and is making the efforts very difficult. So whether this platform can think of a first, number one, the consortia of the institutions involving private and donors, the academia, and then having its own constellation of the high resolution satellite. So I believe that the foundation like Melinda Gates Foundation can help in our endeavors to achieve that. So this is my suggestion to this elite group is. Thank you very much.
Thank you, Ajit. Please go ahead.
I guess I feel kind of addressed on this comment. So first of all, thanks for your kind words on the Sentinel. And I think, yes, we are trying. I think accessibility and availability are not necessarily the same sometimes, right? So we make everything accessible, but it doesn't necessarily mean that it's available to everybody all around the world. So we are focusing on that a lot. Actually, we work also with development cooperation partners like the EU on expanding that. We're currently building a Copernicus Center both in the Philippines and another one in Panama as a Latin America and Caribbean hub to make it really much easier, available, and accessible. So that on the Sentinel, we could continue talking there, but I think the point is taken on the high resolution, but it's not as simple as it seems. There's a lot of political components to that, right? We could also go further down. I mean, there is no technical reason why we don't release 5-centimeter data, right? But it's restricted to the military domain. Everything below 30 centimeters is not allowed to be commercially purchasable, right? And at the moment, okay, we have 10 meter as a cutoff for free and open data, if you will. And there's a big commercial market that occupies the space below, right? So if we suddenly now, as ESA, say, okay, we launch a commercial high-resolution constellation, you kill the market. It doesn't work so easily. I mean, okay, we have moved from the 30-meter Landsat to the 10-meter Sentinel, which has been a big step. Before, 10 meters was commercial, right? Now, you move down, and the resolution in spatial terms itself doesn't cut it anymore, but like we look at the colleagues of Planet, right? They have this kind of in between the 10 and super high resolution with their doves, but they have the increased temporal resolution. We shouldn't forget the temporal resolution. I think that's a big one. And to conclude, I think that a lot of governments are increasing their efforts on, putting space assets up there, satellites, etc., and the development community realizes it more and more. I mean, there was an investment of the private sector arm of the World Bank in the early days in Planet, the IFC. The European Investment Bank is now doing heavy investments in new space entities and to try to make that data more accessible and affordable, because if you have more assets, costs go down. It doesn't necessarily need to be free. We're just working also with the IDB, for example, who works with the Argentinian government to increase their constellation. So I think there's a lot going on, and if there's more, again, more availability means more affordability. And I think not everything has to be free, but it has to be cost appropriate. Also, Sentinel is not free, just somebody else pays for it. Right.
So I'll just like to add to Christoph's comment there. So I think it's also worth asking when and why the high resolution is actually beneficial to the program. So of course, better segmentation, right? But we're also able to push the frontier on what can we do. Again, doing more with less in that sense. With Sentinel, with Landsat, since we have access to several bands beyond optical, there's a lot of signature that's available through remote sensing science in the multiple bands for a variety of climate-related applications, socioeconomic sensing metrics as well. And even as Planet and others continue to release hyperspectral imagery and other information like that, there's a lot more capability that could be available. So sometimes I think the question that we could ask ourselves is, can we be creative in terms of the techniques that we're bringing to bear on the same corpus of information to improve the applications?
Yeah.
Somehow
just because, hi, Kunwar, may I add a comment?
Briefly, Rocio, thank you.
Thank you. Just because Planet has been mentioned, I feel compelled to it. I want to emphasize that, yes, Planet it is a private corporation, but it's also a public benefit corporation. And it has two programs that I would love the audience to check. One is a non-for-profit that was launched this year and has really reduced prices for any non-for-profit. And the other one is the one I work in, which is the science program that works with NASA, ESA, and as well has a basic free license for any university-affiliated person. And we have basic users for free in over 120 countries. You can get daily 3.7 resolution data of the whole Earth. So I encourage anyone to check on that. Of course, you won't have the higher resolution 50 centimeters data or the hyperspectral, but it is a wonderful database, and I'd love to be put in use. Thank you, Kunwar.
Thank you, Rocio. Today, clock has been running faster than usual. So with this, I will thank panelists and thank all of you for participating in the session. And with this, I will end the session. And please have a coffee and engage with the panelists during the coffee hours. Thank you, and I appreciate your patience.